Alright, fine. I will be explaining the Aldair'S equation for ligand binding to a dimeric protein very quickly. Now, to solve this, let's consider a dimeric protein. This is a dimeric protein, E2, that is an enzyme having two binding sites. If one substrate binds to the enzyme, only one of the binding sites will be occupied, so we'll have E2S. Now, the binding constant for that equation, for that reaction, will be concentration of the products all over concentrations of the reactants. This is how we got this. But remember, the enzyme have two binding sites, but only one is occupied. So we can still take this one here and we add another substrate to the remaining binding site to fill up the enzyme active site. So we have E2S2. Now the enzyme is saturated. If you write the binding constant for this second reaction, we'll have the concentration of the products all over concentrations of the reactants. This is how we got this. Now the next step is fractional saturation. Now fractional saturation given as by Y is enzyme bound all over total enzyme. Now enzyme bound, that is enzyme that is attached to substrates all over the total enzyme present. This is represented as this. Fractional saturation is enzyme bound all over total enzyme. Do we get that? Now this is equal to, this is the enzyme bound all over. Now the total enzyme is equal to enzyme that is bound to substrate. This is the total enzyme. This is the total enzyme. Enzyme bound plus free enzyme will give you the total enzyme. So if you want to find the total enzyme, it's just the enzyme that is bound to substrate and the free enzyme. The next is, but E2, that is ES, that is enzyme bound, is equal to E2S gotten from here plus 2E2S2 gotten from here. This 2 can be accounted for experimentally. So just know that ES is equal to this plus this. These are the two bound enzymes. Good. Now the total enzyme is giving us E2, which is the free enzyme, plus the enzyme bound. This 2 is also accounted for experimentally. Now apart from these two assumptions, this 2 and this 2 here, now the next thing to do is we are going to substitute these values into the equation by Y. Please, anywhere you get lost, just pause the video, go back to the video and watch again so you get, and any question you have, feel free to send it. I will respond immediately I see it. So now this is fractional saturation. Fractional saturation is equal to, now instead of putting ES, we now have a new value for ES, which is this. So instead of ES, we put the whole of this, ES2 plus this. Do we get? Because the whole of this represents ES all over ES again, but ES we have a new value, so we have the whole of this as our ES plus E, but our E now is now 2E2 plus ES2, which is the same thing as this, E2S plus 2E2 gotten from there. So we're just substituting what we have here into bar Y to get this. The next thing is we can factorize. Since this is E2S and this is another E2S, we can add them together to get 2E2S, 2E2, and this. Do you get that? Now the next thing is factorize. The next thing is to factorize, and to factorize now we have bar Y equal to, now look at this, the numerator remains the same from there, but the denominator now, since we had 2 here, 2 here, and 2 here, we can bring out 2 from outside the bracket. That is to factorize out 2. But recall that KB1 is equal to E2S all over this. If we cross multiply this, this is what we are going to have. So this, from this KB1, if we cross multiply, we'll have E2S equal to this. From KB2, which is this, if we cross multiply, we're going to have this. So with that, we are now having a new value for E2S and a new value for E2S2. The next thing is we substitute KB1 and KB2 into bar y, into this bar y equation here. So meaning anywhere we see E2S, we put this. Anywhere we see E2S2, we put this. Do you understand? So now bar y, which is my fractional saturation, will be equal to, instead of putting E2S, I substitute the whole of this. So I add this. Plus, instead of putting E2S2, I put my 2. But we have another value for E2S2, which is this. But if you check from here, E2S2 was not, E2S2 was equal to E2S, right? But E2S, we have a value for E2S. Like we have another value for E2S, which is this. So if we substitute this value here, this whole stuff here, in place of E2S, we'll get to this. Try it out. Substitute this in place of E2S and open the bracket. You see, you arrive at this. Now all over the denominator, now we have 2. E2S, we impute our value of E2S here, plus now E2S2, the same thing here, we impute it here, plus our E2, this E2 here. We can factorize E2, since it's common, we factorize E2 out, so we bring out E2 in the numerator and the denominator. You discover that E2 will cancel E2, and if that happens, this is not part of this. If that happens, if E2 cancels E2, we are left with this, and this is our Aldair'S equation. This is our Aldair'S equation for ligand binding to a dimeric enzyme. I know it's a little bit long, but take it step by step and you'll get it. Thanks.